You're welcome to my channel, Mindset Academy, where we want to solve a problem involving CAM in technical drawing. Now, and the question goes like this. It says, design a CAM profile to give the following motion to a ruler 25.4 millimeter in diameter, dwell for 90-degree CAM rotation, rise 40 millimeter with simple harmonic motion for 75 degree of the CAM rotation, dwell for 30 degree of CAM rotation, fall of 40 millimeter with uniform velocity for 75 degree of CAM rotation, dwell for remainder of the revolution, least radius of CAM 50.8 millimeter, line of action through center of CAM anticlockwise rotation. Now, when you are given a question like that, you have to tabulate it. You write them in a tabular form here, this way, right? And you write each of them just like the question suggests. It says the least cam radius of the cam is 50.8 millimeter. The dwell for 90-degree cam rotation, rise 40 millimeter with simple harmonic motion for 75 degree, dwell for 30 degree, fall of 40 millimeter with uniform velocity for 75 degree, dwell for the remainder of the rotation. Cam rotation is anti-clockwise. Follower type ruler diameter 25.1 millimeter, follower rotation clockwise. So the first thing you do is for you to draw your horizontal line this way, right? You can see that. Then you also draw your vertical line this way. You can see that. Now this is where they are meeting. Now what you do is you can use your scale. 1 centimeter equals to what? 30 degree, right? So each of them will be what? 30 degrees. So if I start from 0, I will mark it up to 12. This is 0, this is 1, this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So from here, I'll just name them. My 0 degrees here. So we have what is called the 30 degree. So this is 30 degree. This is 60 degree. This is 90 degree. We have 120, 150, 180, 210, 240, 270, 300, 330, 360. Can you see that? Now, after I've done that, the next thing is I'm going to put the rise, or we'll call it the lift, which is 40 millimeter. So I'll just measure half of 40, which is 20 here, 0 to 2, right? And I'll place it at this point. And I'm going to mark 20 and 20 here. But since we are told that the rise is simple harmonic motion, we're going to draw a semicircle. Can you see that? We'll draw what? A semicircle. Now I'm going to use my meter rule and I'm going to draw a line this way. Then I'll close it up, each of them. You can see that. So we'll start and see how the profile diagram will look like. So it says dwell for 90 degree. It means that for the first 90 degree of the revolution, it is at rest. So I'm going to tick in here. Can you see that? Now the next one is saying us that it now rises for 75 degree of the rotation. Now look at what is happening. It rises with what? Simple harmonic motion. So for the next what, 75 degree of the rotation. So this is 90, right? So we have from 90 to 120 is 30, from 120 to 150 is 60, then in between 60 and 180 is what, 75, right? So that means I need half of 150 and 180. That will be what? 5 millimeter, because we said 10 millimeter represents 30 degree, right? So 5 millimeter represents what? 15 degrees. Is that okay now? So if I should take that up, that part up, that's what I'm doing here. So now it says it rise with what? Uniform and simple harmonic motion. Is that taken? So let's see. So you can still take half of this again, just for we to, because we want to divide it into 4. So I'll take half of it again here. This is half of it here. We're going to take it up. And see that? So we have 0, 1, 2, 3, 4. So if this will be my 75 degree here. That's why I'm doing it that way. So I'm going to divide here into 4. So making use of my set square. See what I want to do. I'll close it up, right? And I'll divide the rest into 8. So remember that you can divide it into 6 or into 4, any of the two. This is what we have here now. So if I move the first one from 0, the first one will move to 120. Can you see that? The second one will move to 135, which is here, 135. So it will move to 135. This is the 135 here. Can you see that? And the next one will move to 150. Can you see that? Then the next one will move towards 75 here. So this is 75 is at this point here. That will go to stop here. So between 90 and 165 is 75. Is that okay now? So this is what we have from this point to this point to this point to this point and this point, because it said rise and it must reach the final point here. Is that okay now? So now we move forward to the next one, and say it's now draw for another 30 degree. So from this aspect here now, this is 75. They will move from 75. We have 180, that is 15. In between 180 is another point again. That is from 75 to 180, 15. This is 30. This will be that will be 30 here. So it will be at this point here. Do you understand what I'm trying to say now? In between 180 and 210 is 30 degrees. So half of 30 is what? 15. So if I take that up this way, so that means from 75, from 135, right? From 165 to 2 to 195 will give us what? 30 degree. Is that again? So dwell at that distance there. So I'll just put my line here this way. It's dwelling there. So this is 30 degree of the revolution between 75 and what? 195. 195. All together. Now we'll continue. Say now for 40 millimeter UVL. So it's 475 degree with what? Uniform velocity. So let's see what 75 will give us. So from here now we have from this point, this is 15. From 195 to 210 is 15. 30, 45, 60, right? After that 60, we have 75 here. So it falls straight ahead to what? 270. So from here, for UVL, use straight line. altogether. For UVL, use what? Use straight line. Because if you calculate from 195 to 270, the distance between them is what? 75 degree. Because 75 plus 195 will give you what? 270. Is that taken now? So we move forward. Now it now said what? It dwell for the remainder, meaning that from here to the last point here is at rest. Is that taken? So we are going to use my French curve here to join this point here. So let me do that and let's see. Use my French curve here to join this point here. So I can just use this from this point. So you can see that. So this is what we have here. That again, it dwell for the first 90 degree. It then rise with simple harmonic motion. Then it dwell for the next 30 degree. Then it fall with uniform velocity for the next 75 degree and remainder for the rest. So what I can easily do here is that at this point here, between 0 to 90 at this point, it dwells, right? It dwells. Then between 90 to this point here, it rises. Then from this point, from here, from 175 to this point here, it dwells again. Then between 195 to 270, it falls with UVL. Then from 270, it dwells. So what I can easily do here is just to show you what's really happening here. And let's draw this way. Then in between this point here to this point here, just put my arrow. Then from this point here, I'm going to put another arrow here, right? Then here also dual. Then from 270 here, then dual here. We have there all together. So let's move forward. So this is the displacement diagram, the cam profile diagram. So let's see how the displacement diagram look like when it is rotating. So if I'm to draw the displacement diagram here, what I'll simply do is just to draw my horizontal and vertical line. I can start from here. Is that again? I can virtually start from here and draw my vertical line up this way. Then I'll draw my horizontal line also this way. I'll draw my horizontal line too. So you just draw your horizontal line too this way. Hope you can see that. So what they said is the least cam radius, since I didn't give us the cam diameter, they only give us the least cam radius. We are going to measure 50.8 millimeter on your meter rule from 0. This is 50.8, almost 51, right? And I'll place it at this point here. And I'm going to draw a circle. right? And the rise is what is 40, right? Which is just from here to here, 40 millimeter. So I can just from here place it on top of the least cam radius or the minimum and to be at this point here, right? So I'll come here to this point. I'm going to draw this. Hope you can see that, right? So once we've done that, the next thing is to try and divide it into 12 equal parts. So I'll just place it here and I'm going to mark up. I'll place it here also. I'll mark up. I'll place at the center. I'll mark left and what and right. So I can take my meter rule and draw my line towards the center of it this way. I'll come here also, I'll do the same thing here too, this way. I'll come here too, through the center, this way. I'll come here too, to the center this way. You can see that? Now the good news here is just we're told that the cam rotation given in the question is given to be anti-clockwise. So the cam rotating anti-clockwise this way. So the ruler will go in clockwise. So I will moving in this direction this way. This is how we are moving. Since this is going in this direction this way. Are we together? So when we are doing that, so this will be 0 degree. There will be 30 degree. Here will be 60 degree. This will be 90 degree, 120 degree, 150 degree, 180 degree, 210 degree, 240 degree, 270 degree, 300 degree, 330 degree, then back to what 60 degree here. Can you see that? So we start and see what we can actually do here. So what we are told it is what it is roller, right? So the roller will be at this point here. This is where I'm going to draw out the roller. Start taking. But before I start doing what I'm doing, we are given that uh, for the first 90 degree, it is what? It is dwelling, it is at rest. And what is the roller diameter? The roller diameter given is 25.4. So when you divide 25.4 divided by what? By 2. We have 12, we'll be having, so 20, 20, 25.5 divided by 2 will give us 12.7, right? So I'll just take my meter rule and I'll measure 12.7. This is on 0 and this is 10, 11, 12, 12.7 is just very close to what? 13. All together. So I'll place it in this point, each of those points from 0 to 30. At this point, I'll have this faint line. At this point, so I have another one, faint line. At this also, I have another one, faint line, right? Then this one here will be thickened. So I'll thicken it. The initial one will be what thickened. Now we'll move forward. Then we move from the next one, we have 120. So once I place it here for 120 at this point, hope you can see that. Then I'll come to 120 on this least cam radius and I'll mark at this point. Can you see that? I'll come again. The next one we have is 135, right? So 135 is just in between 20 and 150. So I can easily bisect it in order to have that. So if I bisect it this way, right, I can use anyone. I can use this. If I bisect it this way, I bisect here, I come here also, and I bisect here in any way you want it. So where they meet will give us half of it. So at this point here, this is 120. If you add 15, if you divide between 120 and 150 is 30. Divide 30 by 2, we're having what, 15, and this will give us what, 135 degree altogether. So if I just take it to 135 at this point here, from 0 to 135, then I'll come to this can radius here. I'll check an arc. So at this point, is another point here, very important point. We're coming back to it. Then the next one is 150. So I'll move from 150, I'll come and touch up here, right? I'll place it on this can radius 150. I'll mark here, which will be here. Then the next one is what? After 150, then the next one will be 150 plus 15 again. So if I take half of this and I cut here also, this will give me 150 plus 15 is what? 165, right? So that's 165. I'll just draw my line through that point. 165, right? So place it there from here. This is 165 from here to touching just the main point here. So it's dwelling from 165, right? Don't forget this is 165 here. It's dwelling from 165 to where? To 195, right? So it dwells from this point to this point. The 195 is in between 210 and 180. So I'll still take half of it also. From here to here is half of it. And I'll mark. So this will be what? 195. 195. So I'll just draw my line this way. I'll draw my line this way to have 195, right? So the 195 is here also. So they are traced. So from 165 to 195, from 165 to 195 is dwelling. Then the rest one is what? Fall. So it starts falling from this point to this point. So from here now, I'll take it to this point, to this point, right? Where it starts falling, where it intersect with it. From 210, I'll come here. I'm going to mark all together. Then the next one is I cannot go to 240 also at this point. Place it on 240, mark. Then the next one is what? 270 is just on the line, which is at this point here. So from 270 back to 360, they are all dwelling to this point here. So what I'll just do is to complete it is just to draw my ruler follower there at every point. This is the ruler here. This also here is another ruler. This is a ruler too. This is another ruler. This is ruler here too. So do that to every point there. So every point here too. To here too. So from here to at this point. From here to at this point. So I'll use my French curve and I'll join all this baseline here tangential to it at the base, right? So let's do that and see. So from this point, we'll join it using so this is what we have here in terms of drawing. This is what we call the displacement diagram for that particular question. Is that taken? So this is what we have here. we successfully drawn out the displace and the profile diagram. This is the profile diagram. This is the displacement diagram, and this is the movement of the cam, right? So if you have found the video helpful, please don't forget to like, subscribe, and also share the video. Thanks for watching.